Welcome back, Algebros. We arrive at the final boss of solving quadratic equations with something known as the quadratic formula. We've already seen a couple of methods, but both rely on very specific cases, either where it's x squared but no x. We've seen ones where we can use factoring strategies, but not always can we do that. Our factoring strategies are fairly limited to either if we have a common factor or if the leading coefficient is 1. But can we find an end-all, be-all formula to solve any quadratic equation in expanded form? By expanded form, what that's going to look like is ax squared plus bx plus c equals 0. Does a such thing exist? Well, yes, as you can see from just a couple of inches below. This thing is called the quadratic formula. For any quadratic formula that looks something like this, where a, b, and c are all real numbers, we can utilize the a, the b, and the c in order to give us this fancy formula. And this actually gives us two values, thanks to this plus or minus. It's negative b plus or minus the square root of b squared minus 4ac, all of that square root, all divided by 2a. This is a complicated formula now, isn't it? There's a couple of ways you can memorize it. The boring way that I've heard from other schools is using Pop Goes the Weasel. But your pal Mr. K has another way of going about it. And when we do our public discussion in class, you're going to hear something you've never heard before. Keep in mind that the original equation that you derive from must be an expanded form, so this form up here. Similarly, because this will give us two solutions, there will be a split at the plus or minus, and we're going to see that in just a moment. All this is a matter of just replacing a, b, and c by their values. So when you're given a quadratic equation that looks like this, we can't use any factoring strategies or the square root method, so instead we have to just go with the quadratic formula. It's sometimes good to just write it from scratch. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Now I know this off the top of my head because I've been teaching algebra for 5 years, and I'm a math teacher, of course I know this. You'll pick up on it too, whether it's from the song or just by getting more practice, which you should be doing. Now let's replace each individually. From this equation up here, a is 2, b is negative 5, and c is 3. A is the thing on x squared, b is the thing on x, c is the thing on 3. So, if b is negative 5, then negative b will reverse it again to just become 5. Plus or minus, we're going to leave that there until there's nothing else we can do. B squared is going to be negative 5 squared. Negative 5 times negative 5 is going to be 25. Minus 4 times a is 2, so replace it with 2. Times c is 3, so I replace it with 3. All divided by 2 times a is 2, replace it by 2. It's all just a matter of keeping track of what a, b, and c are. It looks complicated, but you really need to practice it, and you should follow my steps step by step while dealing with another problem in order to really get the hang of it. So we continue. 5 plus or minus the square root. We operate inside the square root as if it were parentheses, so we perform order of operations in there first. So it's going to be 25 minus 4 times 2 times 3. That's going to give you 24. All divided by 2 times 2 on the bottom is going to give me 4. I'm going to move to work up here. It's going to equal 5 plus or minus 24. 25 minus 24 is just 1, divided by 4. 5 plus or minus the square root of 1. We're going to assume it's just 1 in this case, because we already have a plus or minus. All divided by 4. So here, this was all that the square root of 1 is just 1. Here's where we split. There's no other operations I can really do here. So I'm going to split this up into 1x is going to equal the positive version of the plus or minus, so it's going to be 5 plus 1 over 4. And the other version is going to be the minus version, so x will equal 5 minus 1 over 4. 5 plus 1 is going to be 6, so it's going to be 6 over 4. which just equals 3 over 2 when you simplify it. Always simplify your fractions. Or it's going to be 4 over 4, which just equals 1. And there you have it. That is a quadratic equation solved by using the quadratic formula. A question you might be asking is, wait a second, can this be applied for even the equations before, like the ones that could be solved with square roots? Why, yes. Because if you had something, say, like 2x squared equals, say, 49. Sorry, not equals 0. What that would amount to is, we need to move the 49 to the other side to get 2x squared minus 49 equals 0. Suddenly, a is 2, c is negative 49, and since there's no x term, b is 0. So yes, this works for just about everything. Let's give another one of these a try. For 4x squared plus 4x plus 1 equals 0. Once again, let's write out the quadratic formula as it is. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So b here is 4, a is also 4, and c is 1. So let's replace. Negative b will be negative 4, plus or minus the square root of b squared is going to be 4 squared, 16, minus 4 times a, which in this case is 4, times c, which is 1, all divided by 4 times 2. Negative 4 will remain the same, plus or minus the square root of 16, minus 4 times 1 is also 16, divided by 8. So negative 4 plus or minus 16 minus 16 is 0 over 8. Here's an odd one here. The square root of 0 is just 0. So it's going to be negative 4 plus or minus 0 over 8. Because I have this 0 over here, we don't have to split. We don't have to split, so now it's going to be just negative 4 over 8. Simplify that down to be negative 1 half. Nice and easy. So in this case, we didn't have two solutions. I just had one solution. The previous one, I had 3 over 2 or 1 as possibilities. So this was 2 solutions. What does a 0 solution look like? Well, if you remember what things looked like when we took square roots, you might already know where this is going. Let's see with this example, 2x squared plus 3x plus 10 equals 0. So it's going to be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And let's go start replacing. A is 2, b is 3, c is 10. So here I'm going to have negative b is negative 3, plus or minus the square root of b squared will be 9, minus 4, times 2, times 10, all divided by 2 times 2. Negative 3, plus or minus the square root of 9, minus 4 times 2 is 8, times 10 is 80, over 4. Now this is going to equal negative 3, plus or minus the square root of 9 minus 80, will be negative 71 over 4. Stop right there because, oops, we have a problem. We've said before that square roots can't have a negative inside. In this situation, this kind of looks like before, where the number we were trying to get the square root of can't be negative. So in this case, if you have a situation like that, you can't proceed, so you have no real solutions. You do have something called imaginary solutions, but I'll leave that as a surprise for you in Algebra 2. This is a heck of a ride for a mathematical process. You need to get your hand used to it, you need to memorize the formula, and that's why these UTRIs are important. So I really, really emphasize when I say, do it! And I promise it'll become more natural in no time. I'll see you at the end.